Okay, let us start with the seventh question. Start the timer. Okay. A book of mass M lies. There's a mass M here. There's a standing on one more platform, capital M here. And then there's a person who is pushing this with a force F here. So as a result of it, both the masses are moving together. So why should it move like this? See, there's now glue over here, but still this mass is on top of it. Why does it happen like this? Because there's a friction here, right? What does the friction do? Friction is holding this one and moving it. Now what is the direction of the friction? Now you see, when this is trying to make it move like this, the same force, similar force will also be acting like this. Frictional force will be acting like this. Now what is this frictional force? In order that there is no motion between them, the frictional force between them is nothing but frictional force should be equal to mu times m, because it's in a static region. Now what is n? N is nothing but mu times mgo here, right? So therefore, now what do we have here? So this frictional force should be equal to m into a. M into a should be equal to mu times n. M and m cancels. So you have a is equal to mu times g. So the answer is B over here, because he is asking you about the acceleration of the object, right? What is the maximum acceleration? How much acceleration that you can apply, so that you see to it that both the blocks slide down, slide together. That's what it says. The book does not slide backwards relative to the table. So it means that this moves forward in relative to this. Okay, it appears that it is moving backward. Did you understand this question? So it is something like when you are moving forward in your car, it appears that the trees are moving backwards. This question is related to something like that. Okay, let us move on to the eighth question.